All right. Good morning, friends. My name is Ben Sarti. I happen to be a facilitator or trainer, and we're gonna dive right into battery-based inverters for standalone systems. Inverter play a factor role, a very important role when it comes to PV systems that includes these AC applications. So anything that has to do with AC usage of appliances, AC loads with AC loads, inverter has to be included because the DC have to be converted into the AC and the inverter is the mediator. The inverter stands in the middle between the DC sections of your installations and your AC section. So that's exactly what the inverter does. Now, let me dive you right to our learning objectives. We're going to specify a battery-based inverter. We're going to be giving electrical loads and surge requirements. We're going to describe various configurations for syncing and clustering multiple inverters. We're going to examine inverter and charge controller size considerations. We're going to describe the multi-wire branch, socket wired, and concerned with single phase supplies. Let them move forward. The objective is also already specified. Now, when it comes to standalone inverter, there are a lot of choices out there, but the two key factors to understand is that you either have an MPPT inverter or a non-MPPT inverter. MPPT inverter or a non-MPPT inverter will go forward. Inverter only cannot charge battery from AC source. So if you have an inverter that is just an inverter only inverter, it will just what invert the current, but it cannot charge and start the battery. And it has no source from the AC, which means you cannot use the grill like LEC, or you cannot use a generator to charge. You cannot use an inverter to charge the battery. You cannot because it's just an inverter only. Inverter slash charger. If you have an inverter charger, that means your inverter has should have the ability to convert AC source to DC to charge the battery. So it also converts DC to AC and then AC to DC. So that is called an inverter charger. Generator power or grow direct PV inverter output. Then we have inverter types. We have multi-field, the multi-field sense wave, the modified, the modified sine wave inverter, and the lower quality waveform. The lower quality waveform inverter. You have the pure sine wave. We have high quality low distortions. Pure sine wave output required for system operating sensitive equipments and loads. Not all true sine wave are equal. Not all true sine wave are equal. At first, let's start with a review of some key battery-based inverter concepts. The basic functions of an inverter is to what? Convert DC from battery bank to PV array to AC power load. It cannot use power from an AC charging source like a generator to charge the battery. First, let's start with a review of some key battery-based inverter. The basic function of an inverter is just to convert DC from the battery bank or PV array to AC power. An inverter or inverter charger is a type of inverter that also includes a battery charger, which can take power from an AC source such as a generator or the grill (LEC) and convert it to DC to charge the battery. You will have the time to read the material on your own. I'm going to summarize. Now, when we talk about modified sine wave, the SLS, MSW, MSW inverters produce an AC wave with clean step, a result of switching topology of the inverter. The SMW inverter work fine for many applications and tend to be less expensive than sine wave inverter, but are not suitable for all load. Some load that have difficulty operating on a modified sine wave include the sensitive electronic device that require high quality power, dimmer switches, laser printer, charger for some cordless cell phone ceiling fans. Sine wave inverter are manufactured to produce verifying level of verifying level of power quality. Now, take into consideration if you are purchasing an inverter for your home or for the customer or your client, there are inverters that cannot handle certain load. That's what it's saying here. If you have a modified sine wave inverter, they're saying here the ability to switch between the topology of the inverter. They work fine for many applications and tend to be less expensive than sine wave inverter, but are not suitable for all load. It's cheaper, but it's not suitable for all load. Some loads that have difficulty operating on a modified sine wave include sensitive electronic devices that require high quality power, like dimmer switches. We have lights that dimmers. We have laser printers. So if you're doing an installation for a commercial based system, you should take into consideration if you have a modified sine wave inverter and they have printers in that facility, the inverter will not be able to produce or invert the DC power to be able to handle some of the loads. So you have to take that into consideration as a designer, as a system designer. When you're designing the system, also take that into consideration when making the decision of what inverter to use for a specific job. Let's dive in. Specifying standalone inverter, normal battery bank VDC, the normal battery bank the volt, the DC input voltage, the AC input, the AC loads, the AC output frequency, hertz, and voltage, the total design VA, the total surge VA. Additional features require all design, additional features require all design. The generator integrations, frequency, and voltage can integrate with battery technology, the BS and BMS, low shading capacities, seal or inverted chip classics design, operating temperature range, cooling system, remote metering, programming, and data monitoring. A lot of information is needed to accurately specify a battery-based inverter. Number one, the inverter DC input voltage. You must have that information at hand. Must match the battery bank normal voltage and the AC voltage and the frequency hertz. All should match. That is why it is important to read the, um, the data sheet of your model, the PV model panels, and the inverter also has the manuals that we all the manual information is the installation manuals or the data sheet as well that tells you these information you need. And most of them are actually on the nameplate. There's a plate attached to the inverter, and there's a plate attached on the back of your PV model that will give you information, some of these key information you need when it comes to sizing your inverter. In some systems, transformers are used to create voltage compatibility between sources and devices. Most inverters come from the factory with a set normal DC voltage and AC output frequency and voltage that cannot be adjusted in the field. It is very important to order the correct inverter for a specific job. Inverters that are typically used in standalone systems come with many different options. We have inverter and inverter charger. Have the ability to use the AC have the ability to use the AC from the generator to charge the battery. So if you have an inverter charger, I mean, the inverter has also have a charge controller attached to it. That inverter has the ability to also be connected to also sync with a generator to charge your battery. So it's very important to know if the system is built, the client has a standby generator. You need an inverter charger that in days of autonomy, days that rains, days that cloudy days, the system can be charged. The battery of that system can be charged from the AC import from the generator, standby generator the customer has. That's what it's saying. Now, for lithium ion battery, most of them, the newer technology, they also have an integration management system called the BSM. It has what they call the battery management system that monitors the battery charging and discharging to protect it from damage. So lithium ion has its own BSM system. Most of the batteries now, like lead acid batteries, You will be looking at your charge controller or your inverter charger readings to understand the input or the settings of your battery. So it's very important. Many advanced standalone inverter or charge controller have low shading capacity. This means that as the state of charge or voltage of the battery gets below a specific point, the inverter charger will open a relay which will disconnect a load or loads. This prevents the battery from becoming fully discharged, which may cause damage. It also allows more critical load to continue to operate longer by reducing the total load on the battery. So many advanced standalone inverter chargers have load shedding capacity. So you want to read about the inverter you're buying. If you buy a cheap inverter that do not have some of these key technology or these key abilities, you may be having problem with your client. It's very important to understand when starting your inverter. There are very important factors to understand. Let's dive in. Normal battery bank voltage considerations. Inverters are pre-configured for single normal battery voltage. The normal voltage standalone systems are typically 12 volt, 24 volt, or 48 volt. 12 volt used for very small systems, typically DC only. Even they're getting scarce on the market. It's kind of difficult to find 12 volt PV model these days because the 24, 48 volt are more cheaper. So also take that into consideration. And then that has to do with your battery sizing as well. The difference is that if you have a lithium ion battery, you cannot pair them in series or parallel to step up the volt. I can pair my battery into series if I have a couple of 12 volt batteries. I can pair them into series of four, 12 times four. Um, we give you 48. So I can pair them into series of four and I'll be able to get a 48 volt system, a battery bank. So that's one of the things. So battery sizing, you must take into consideration the voltage. Voltage matters. There is a need for a specific battery volt, DC load, or integrations with a separate DC power system. May have battery pre-packaged with inverter. DC voltage not always stand on specification. So that's what it's saying. As we mentioned previously, most inverter come from the manufacturer set to a specific normal DC battery bank voltage. The most common voltage for standalone system are 12, 24, and 48. Most inverter cannot be reconfigured in the field, so be sure to specify the correct voltage when designing and purchasing equipment for a system. The choice of normal DC voltage often comes down to the size of the system, available equipment's voltage, and designer or customer preferences. 12 volt is most commonly used for very small systems such as mobile system in recreational vehicles, RV, campers, and so forth. Um, Now, 24 volt systems are also usually small and are becoming less common. 48 volt is typically used on larger systems and is most common for systems with PV array uh, over about 3 kilowatts. Some newer battery systems like lithium ion may only be available for 48 volt systems depending on the manufacturer. Now, 12 volt, 24, and 48 volt standalone inverter are available through, though not all manufacturers make them inverter for each normal voltage. The inverter manufacturer will specify voltage and battery chemistry option. Typically, lead acid battery can be field installed to NM voltage divisibly by 2. 2 volt is the voltage of a single lead acid cell, up to 48 volt. But lithium ion banks are typically designed to operate at one specific volt. Note that the NEC section 706.30 require battery bank indwelling with live parts accessible during maintenance to be kept at 100 volt. You cannot have over 100 volt battery in the dwelling area in a home. Lithium battery typically do not require maintenance and can be de-engineered, so no live parts are accessible. If there are no user serviceable parts, then they can be installed at voltage 100 volt for dwelling units, although voltage above 48 volt are currently uncommon in standalone systems. I hope you understand what I just read. Simplest saying here is 12 volt are actually being used for very small system. Now for recreational systems in America and developed countries, they have something called RVs, a small mobile, it's a car, it's like a bus, but you have like a home. You have everything in it. You have TV, you have bed for your family. Your family can go on a trip using an RV. I don't think it's very common in Africa. I haven't seen none, but it's common in developed nations. 12 volt is very common because the systems is small and handles small loads. But when it comes to designing a system above around three kilowatts, that's 3,000 watts, then you should be able to move over to a 24 volt system or a 48 volt. Most systems now are more likely 48 volt systems. Common AC volt and frequency configurations. USA, some Caribbean, Central America specific island countries say 60 hertz, 120 volt normal, 120 to 240 split phase. Various three-phase configuration 208, 120, 480 to 277. Most of Europe, Africa, Asia, Australia, New Zealand, and South America, 50 hertz, 60 to 330 volt normal. Phase split or three. So they're talking about the common AC voltage used. In Africa, we use commonly 200, 220 to 200 volt. That's what we use in Africa. 220 to 240 volt. And the standard AC volt and frequencies vary across the world. Voltage and frequency provided by the utility grid is often called the service or the main voltage. Even though standalone systems are not connected to the utility grid, the AC appliances available in the region will be configured to work with the parameters of the load or the local utility. Also, in area where the utility grid may not currently be available, it is a common idea to design a system in a way that can be easily integrated with all having to upgrade equipment should the grid become available. For example, there is no government lights or LEC in over, let's say 80, 90%, 95, 98% of the areas in Liberia. Now, you can say, okay, since we don't have LEC, I'm going to design a system that it will handle only 110 voltage. What if in the future there's LEC there and the customer would like to include and have to have both? They want to be able to use the LEC use the LEC as well, and they want to use the PV system. Now they have had all these um, 110 appliances, and the LEC is giving 220 to 240 volt. Now it's going to be a conflict. So you always want to design your system based on the local voltage, used by the geographical location where your system is being configured. That's very important. Except the customer specifically says, look, I'm from America, all my appliances are 110, I want a 110 system. That comes into play. All right. You guys will read yourself. I'm not going to read everything word by word. Comparing inverter AC options. Now, the US manufacturer of the domestic, international, or export model, the international manufacturer, US or non-model, may be fee adjustable, but not usually. Now, up-back inverter specifications. The normal DC voltage is 12 volt. The continuous power, 25 degrees Celsius to 2000. We have 2000 VA. The AC output voltage is 120 volt to 230 volt. The AC output frequency is 60 to 50 hertz. 60 or 50 hertz here. the continuous AC output current at 25, 70 degree Fahrenheit, 70-degree Fahrenheit, and we have 16.7 amps AC. The maximum input 60 AC, 30 AC. The AC frequency, AC input voltage range 85 to 140 volt. It's 170 to 290 volt. Battery-based inverters are manufactured all over the world, but there are three most common AC output configurations. You either have the 120 volt DC Hertz, 60 Hertz, 120 to 240 volt 60 Hertz, 230 volt 50 Hertz. Manufacturers will typically make different models of their inverter that are compatible with the typical voltage of different countries or regions. Often the model that does not match that voltage and frequency where the manufacturer is based or national or export versions. For example, a United States-based company, a company that is producing inverter in the US, may produce inverters that can handle 120 to 220, 240 volt. But commonly, typically in the US, we use 120 volt. So that shows that they are producing the export version of their product so that that version of the product can be exported or bought by other countries or by businesses or institutions from other countries. That's what they're saying there. We'll move forward. Energy versus power. Energy battery needs sufficient energy, compact capacity kilowatts hour to meet durations requirements. Power. Battery and inverter need sufficient power capacity kilowatts to meet peak load demand. So energy and power, they are intertwined, but they're different. Do not confuse energy or power. When sizing a standalone system, we need to consider both energy and power requirement of the load. The battery bank will be rated by the amount of energy it can store in either wax hour or amp hours, depending on the technology. If you use a lithium ion battery, you will be calculating your storage capacity in watts hour. If you use a lead acid battery, lead acid, we're talking about amp hours. That's what it said, depending on the technology. The battery bank need to have the capacity to power the load for the required amount of time. If the battery bank is too small, it will be full discharged too quickly. If the battery bank is too large, the customer will have spent money on unnecessary capacity. So you have to size the battery based on the loads of the customer. You can just be assumptuous. You can just assume that, oh, we need a bigger battery bank, and you have the person spend thousands of dollars just to run few appliances. That's what we're saying here. We also need to consider the maximum amount of power watts or kilowatts. Maximum amount of power, watts or kilowatts. The load we require, which will be used to size the inverter to ensure it is large enough. The battery bank will also need to have a discharge current high enough to provide the required power for most properly sized battery bank. This is not an issue. If the power ratings of the inverter too low, it will overload. When too many loads are operating, which will cause the system to shut down and may damage the inverter. If the inverter is too large, the customer will have spent money on unnecessary capacity. When sizing a standalone system, it is very important not to confuse power or watts or kilowatts with energy. Watts hour, kilowatts hours, or amps hour. Remember, energy is used when sizing battery bank and power is used when sizing inverter. Energy is used when sizing battery bank and power is used when sizing the inverter. So you should take that into consideration. When sizing battery bank, we're talking about energy. When sizing inverter, we're talking about when sizing inverter, we're talking about what? Power. When sizing battery bank, we're talking about power. I mean, when sizing inverter and generator. So remember, energy is used when sizing the battery bank, and power is used when sizing your inverter. I'll go right down to our chart here. Specifying battery-based inverter, the review load analysis. You guys know about load analysis. You know what a VA is. You know what your average daily energy watts hour is. I'm gonna go over it. Every home or every designer, PV designer, must understand your entire system designs for an off-grid system begins with understanding the loads. And this is a load analysis chart. If you're designing a grid direct system, then we use information from the bill of the customer in developed countries like America. If I'm building a system for a resident American dwellers, I don't have to go in the home and take down all the appliances they have, the load. No, all I have to do, ask the individual for the bill. On the bill has a reading, the kilowatts hour reading on the bill tells you on the average how much kilowatts hour that person used. You use that information to find, to be able to find the system for that dwelling place. Remember from PV 203 and the early load analysis lesson in this course that when sizing a standalone system, it is critical that a thorough load analysis be performed that includes every load that will be included with the system. If loads are not included, or if there is use, if included, or if there is use, loads are not included, or if the use is underestimated, the system will be undersized and will not perform as expected. Now, especially for us Africans, I have had an issue with a lot of Africans, prospective customers. They tend to say, "Oh, I just need it's a three-bedroom apartment, it's a four-bedroom house. You know the basic things that are going to be in there. Don't fall for that. You have to perform a proper load analysis of that home." I had an incident, a lady, she told me, "I'm just going to be using a refrigerator, an air conditioner, light bulbs, TV." Now, when I did my presentation, she said, "Oh, did you include microwave?" And I said, "No." "Did you include this other?" I said, "No." I said, "You told me these are your loads. Now, microwave, we have to factor that in to the load to be able to resize the system to be able to handle the microwave." So that's one of the most important things. But it's new to most of our people. So we had to take our time to explain. Power ratings. The inverter continuous power ratings must be greater than the total design VA. The output power continuous for this inverter here is the Schneider's electric inverter. Now, they're saying that it's 6,800 watts. The overall load, 3022 is 8,500 watts to 12,000 watts. The output power continuous, 6,000 watts. The maximum output current, 60 seconds. The ratings, it will be 102 amps, 220 volt, 52 amps, 240 volt. So inverter continuous power rating must be greater than the total design VA. So inverter can operate load from battery power or generator. Design VA. You remember from our previous trainings on load analysis, we use our design VA, a total design VA. So yeah, total surge VA and total design VA. These two here had to be added, used to size the inverter and generator. When sizing your inverter and generator. Inverter and generator. When sizing your PV array, you use what we call what? You use your AC average daily energy watts daily. This is what we use to size our PV array. This is what we use to size our inverters. As you notice here, there is a refrigerator here. 2050 is the AC average daily energy watts hour for that inverter, for that refrigerator. But that refrigerator also has something else. The refrigerator has surge, it has surge, it has surge load. And power factor is added, we have surge load is added to that refrigerator. So when that is factored in, it add up. So your inverter have to be sized, including the total design VA and your surge load total. You have to add those two in order to be able to get your total design VH. You have to add your total design VA and your surge added to get your total VA, which would be 8,200. 8,200. So this is what we need to size our inverter and our generator. If you're going to have generator, um, a generator that you're going to use an inverter charger. I'm going to read a little bit. Remember from PV 203 and the earlier load analysis lesson in this course that when sizing a standalone system, it is critical that a thorough load analysis be performed. That includes every load that will be included with the system. If loads are not included or if their use is unestimated, the system will be undersized and will not perform as expected. Customers are never happy when the system does not perform as expected, even if it's because they added on anticipated load. The load analysis need to include each load, its power in watts, the quantity of each load, and how often it operates. I have this habit that this little trick I use now. If I'm sizing a system for Africa, and say we size the system and the system is, let's say the system is a 10 kilowatt system. I usually say, since it's a 10 kilowatt system, 10 kilowatts times 1,000, um, 10,000 watts, I will add 5% to this. So I say times 5%, 500, or sometimes I add 20%. So 10,000 watts times 20%, that's 2,000. So if I'm doing a 10,000 watt system design, I recommend I will add 2,000 to it and I'll make it what? 12,000 watts in terms of the PV model, or 10,000, 10,000 or 11,000. The reason is because us Africans has a tendency that once we have power, we begin to start adding loads. We start adding loads on the system. So at the end of the day, there may be, the system may be overburdened, and then they start having problem. And now you, the designer, or you, the technician, or whoever you are, will be the one who will have the bad discussion. They will tell the bad news about your work. Uh, we are very good at that. You can do a perfect job for a black person, African. They tell one or two they will, mm, but let something go wrong, the whole world will know. It is the black man nature, something that's in us as black people. We like to do that. We love it. We tell the bad more than the good. So it is important to to get your back there. Keep asking them, are you planning on using other appliances that you don't have in your home right now? If they don't want to say it, recommend that a system be sized overly, a little bit over what they have. So in the future, they decide to add the refrigerator they were not using. Since they said they have one refrigerator, all of a sudden now they have an Xbox freezer added. All of a sudden they have a microwave added. So you must take those into consideration. Okay. Power ratings, we're talking about that. I'm going to summarize. I'm not going to read everything. There are several different factors. I have to finish it because my son, when he get up, I won't be able to do anything. There are several different factors that must be considered when specifying a standalone inverter. As previously discussed, the power ratings of the inverter must be greater than the total design VA and total surge VA of connected load. Again, if the inverter is too small, it will most likely shut down if the load get too high, which may also cause damage to the inverter. When conducting a load analysis, the total design VAX sum, all loads are all loads are on at the same time. This rarely happens, but it will provide a conservative number to ensure The inverter is sized large enough to handle the load. The surge ratings of the inverter must also be greater than the total surge VA. Loads with a more like a well-pumped refrigerator or table saw have a start-up surge when the load draws a large amount of power for a short amount of time in order to get the motor spinning. Once the motor is spinning, the power required to keep it spinning is significantly less than the start-up surge. Inverters that are transformer based of are compatible of providing are capable of providing much higher surge ratings than transformer-less inverter. Now, if you're going to have loads on that system that has surge ratings, refrigerator is one of the most known or common use load that has surge ratings. You must take into consideration that you need to have include the surge rating. You need to include that into your design and calculations so that when you size your inverter should have the ability to withstand that surge spinning because the motor do boom, it consumes more power. And if your inverter is not sized or does not have the ability to withstand those surge loads, your inverter will shut off. And the customer will tell you every time I want to turn my refrigerator, everything just go off. You can't tell the customer, okay, when you want to turn your refrigerator on, shut down all the other loads and turn the refrigerator on first before you come back and put the other loads on. It's not a good practice. People love convenience. That's why we have drive-through around the world because of convenience. But having drive-through and not getting down from your car to walk into a store for that few seconds that you will be burning some calories make us to lose gain a lot of weight in developed countries because we drive everywhere. Everything is what made for our convenience. Convenience can be good, but too much of convenience can be bad. All right, let's go forward. Specifying the inverter. So the this is specifically when it comes to the inverter. These are important information you might have. On the back of the inverter here, this is the nameplate. The highlighted, the most important information you need when specifying your inverter. The first thing you need to know is the normal battery bank volt. Now this is 48 volt. That battery bank volt 48 volt must match the inverter optional, which is 48 volt. Now it must match. If you're using a lithium ion battery, you have to find a 48 volt lithium ion battery for that system. Lithium ion cannot be paired in series or parallel to up to optimize or to increase or decrease the voltage. If you're using a lead acid battery, you can pair them in series and it will increase the voltage. So that's the difference. Total design VA. That comes to the inverter's continuous rating power. So your total design VA is 7,000 VA. Your inverter has 8,000 VA. Your AC output frequency is 60 hertz. Your inverter is 60 hertz. Match. Your AC output voltage 120 volt. Your must match 120 volt. These two must match. If you have a 20 volt AC output, 120 volt, and you have a let's say 240 volt, 120, 240 volt, and you have just a 120 volt inverter, the system inverter will not even come on because it's not matching. Your total surge VA, we have 8,200. This is the maximum on this inverter, 12,000 VA. So that inverter is a perfect inverter for this size, for this system. This is the requirement for your system design, and this is the inverter option. So you must know if I have a system here and my total design fee is 7,000, I need it, and my battery bank is 48 volt. I must find an inverter. I must size my system with an inverter that has the ability to has 48 volt to match, it should have at least 1,000 more over my design VA. So you see right here, we have 8,000. They're saying here is our total search VA. That include our design VA, total search VA right here. I'm gonna go back to this. Total search VA. This is a total search VA. You add your design VA plus your search add-on, give you a total search VA. Okay. How did we got our design VA? Our AC total operating wax right here. AC total operating wax. This is operating wax. You can see it, but right here, 6,000 plus our power added VA plus our power added VA plus our power added VA equals 7,000. So that equals 7,000. All right, that's how we got 7,000. Now we have our design VA plus our search added. We have 8,200. So you need to understand those informations are very factor. One size in your inverter. I went by right here. All right. Now let me read a little bit. Let's take a look at an example of sizing specification for a standalone inverter. We will use the Outback GS804, GS804, GS8048A. In this case, there are 5 data points to verify. First, does the normal battery bank voltage rating required by the system design and or the DC load match the inverter normal battery bank voltage? In this case, the design required a 48-volt normal battery bank, which we can see match the inverter. Secondly, does the inverter continuous rating power output meets and excel the design load? In this case, yes. The inverter continuous rate power of 8 kilowatts is higher than the total design VA of 7 kilowatts, or 7 kilowatts VA. Third, does the AC frequency of the load matches the AC output frequency of the inverter? In this case, they are both 60 Hertz, the match. Fourth, does the AC output voltage of the inverter match the AC voltage requirement of the load? The load requirement is 120 volt to 240 volt, which does not match the inverter AC output. Fifth, is the inverter surge rating sufficient? In this case, the inverter 5-second surge of 12 kilowatts VA excel the 8.2 kilowatt VA surge of the load on site. See it? The inverter also has an AC input for generator, which will allow for battery charging when the PV array is not producing enough energy. Since the inverter meets or excel all the 5 of the requirements, this inverter is suitable. Okay. Surge solutions. So let's go forward. I'm going to go down a little bit. Consider the potential overload. Possibility of overloading the inverter. Example: system startup, vacation cabin where refrigerator, freezer with dump and well pump all start at the same time. Solution: momentarily turn off large load. So same. Momentarily turn off large load. Generator direct. Example: well pump. Reset inverter. Do not do a desirable solution. Motors that use less power. Automated load management. Bigger inverter. Overload should be prevented if an accurate surge adder is used during the load analysis. That's what I'm just saying. You wouldn't have this problem if you have doing your design, you factor in your surge load. if you do the right thing when designing the system, you will not have problem in the future. So these are instances here. You see right here, we have 800 VA, 8,000 VA, 9,000 VA, 12,000 VA, 16,907 VA. Instantaneous power ratings. Most stringent massive loads start from 16,970 VA. Surge ratings, 12,000 VA. The power ratings, frequency heavily due to load requirement, 9,000 VA. Continual power ratings, 8,000. So for that's what it's saying here. For this power rating on this chart, here they're showing you. Since the current output of any inverter is limited, there may be time where the AC could exceed an inverter maximum output, specifically if the initial system design did not take into account all of the load and the surge requirements. If this happened, internal overload protection circuitry will trip and shut off the power to the AC load to prevent the inverter from damaging itself. Inverters have different current limit level. Some include additional methods of handling momentarily power overloads, which make them better than others at starting load with large surge requirement. In an ideal world, inverters are sized to handle all simultaneous AC load and its surge. Total surge VA is readily loads are often added to a system later, which can result in an overload. One common issue during the initial startup of a system that has been shut down for a while, such as the vacation cabin, is that the larger the AC load will draw the maximum voltage for a certain amount of time before returning to the constant draw. Warm refrigerators and frequency need to work at their maximum. Warm refrigerators and frequency need to work at their maximum to get to the running temperature. An empty water tank need to be filled. When the inverter is turned on, it has to provide power to all the load and simultaneously start the load with large surge demand, which may be too big of a draw from the inverter. One solution is to turn off the large load, disconnecting the water pump or unplugging the fridge or freezer to allow the system to start up first and then connect the large load after a few minutes. In some systems, installing a time delay control is a way to automate this process. Another option for a large load that are not used frequently is to run them directly from a generator. This will require starting the generator before the load can be used. Okay, I want to go down to the chat here. Stocking and clustering inverter. Increase number of inverter to increase system power. If you're going to need to have two inverters, then we talk about stocking and clustering your inverter. Now, parallel stocking, when a single inverter cannot fulfill the power requirement, example, two 120 volt, 4 kilowatts inverter output in parallel create a system total of 8,000 watts at 120 volt. If you do it in parallel, the amps increases, the volt remain the same again. Example, two 120 volt, 4 kilowatts inverter output in parallel create a system total. So the watts will go up. So you have 8,000 watts. So we added 4 kilowatts, 4 kilowatts, we get 8,000 watts at 120 volt. Series stacking, also done to create splits or a three-phase voltage to match AC load or charging source voltage. Example, two 120 volt inverter output stacking to produce split phase 120 to 240 volt. When you pair in series, then you have increased voltage. The inverters are 120. When you pair in series, now you have what? 240 volt. Now you have what? 240 volt. But there's a problem. Manufacturer specific. Equipment must be from same manufacturer. In order to stack an inverter or clustering an inverter, it has to be the same inverter. They must have common requirements. The common requirement, some products do not allow syncing. Some manufacturers make both syncable and non-syncable options. So you have to know that the inverter you're buying, if you are planning to use two inverters to sync for stacking them, you must know that you must check to see if that inverter provides, the manufacturer provides the inverter the options to be sync or cluster. Okay. Stacking inverters, stacking inverters is very specific to the equipment. And in fact, the inverter being stacked have to be from the same manufacturer and likely the same model as well. It is important to consult the manufacturer for details specific to stacking. You'll read about on the manual, installation manual, and read about what are the instructions when it comes to stacking the inverter. All manufacturer has their own requirements. Parallel stacking increases system power at the same AC voltage. May provide redundancies if single inverter fails. Parallel stacking does not ensure the whole system will not shut down. There is a single inverter failure system may need to be reprogrammed to continue operating. Inverter. Okay, I'll be right back, guys. Well, okay, guys, I will be closing this section here, and uh, we will have to continue to the next section of this training. As you can see, I gotta go to my Papa duty, so we have to go to the next section of this training here, and we'll continue our material. We will continue to go down to let me see where we stop at. We stop at page 15, and we have 31 pages, so we have 30 pages. We have 30 pages, so we have 50 more pages to go, and talk about inverters and sizing. So I'm gonna close the series, and then we'll come with the second sections. All right, guys. Okay.